Thank you. So the authors couldn't come, so they gave me the task to come here and speak. I'll try to do my best. Any questions, please, or you can ask now or forward to the authors. So the work is about dissecting the largest national ecosystem of public internet exchange points that we know. Like all the internet exchange points in Brazil are public. So I'm just going to the background of the internet exchange points in Brazil, describe our methodology analysis and what we found. So IXPs, like they're internet exchange points of traffic. Like it's in a simple way, you define that you announce what you want to accept, and you send traffic that you want to get rid of. So it's like a neutral carrier infrastructure. Usually use it like where multiple internet service providers can get together, exchange traffic. You can have like multilateral or bilateral agreements. And the main point of an IXP that we think is that you can have, you can save the connection between multiple points, like in a mesh network, to a single point of exchanging traffic. So in this way, it is you can reduce like the path inflation or the diameter of the network connecting multiple ASs, autonomous systems. In Brazil, we have like now 25 internet exchange points. The first one was built in 2004, so it's really recent in comparison with like Europe and other countries. There are many internet exchange points in some cities in the same state of Brazil. The plan now is to expand this infrastructure to another 16 under internet IXPs. For example, some states here in the north. And this is a public project maintained by a Brazilian National Internet Steering Committee. So all the internet exchange points are public. One of the things about Brazil is that we are among one of the biggest IXPs in the world, the 6th position in the amount of traffic exchanged. Here's the IXP in São Paulo, in Brazil. Have certain around 700 members and at certain peaks of 500 gigabits per second daily. Here's just a curious fact: the measurement of traffic of RIPE in the World Cup of Brazil last year, and during the game of Brazil and Chile, when we went to the shootouts. You can see in the green arrow, like the moment after the end of the game, Brazil won the game. And it's curious, like the point that they say that we can only imagine the relief and the pouring by Brazilians that this dip in traffic represents. It was a good relief, but in the next game we didn't have the same luck. About the research, so we made an analysis of the IXPs in Brazil. So the authors get the data from all the IXPs in Brazil. And this way, I'm going to describe what was done. So first, the data sources. All the data sources we got from the IXP BR, it's a website from Looking Glasses, where you can see the list of all the IXPs in Brazil and getting information from there. Initially, data was got data from the peering DB, but we found that it was like unreliable or deprecated based on the current status of the source. And some of the information that we get, some of the data that we could get, it was directly manually extracted, because some Looking Glasses we couldn't get the whole BGP routing table. So basically the workflow of getting the data was like telnetting into each one of the looking glasses. There's a code for each one. So all the telnet actions were done. After that, we made the BGP queries, get the BGP routing table, community, IPv4 and IPv6 BGP tables, and the AS path summary and the community codes. All this was made in the scripts, automated. All these codes and the data is available online, open source. And then the data was parsed, and the analyses were made based on the graphs used to analyze this data. The tools we used for analysis were NetworkX and Neo4j. So NetworkX more like Python, and Neo4j in Java oriented for analysis on the graphs. So all the data was put inside these tools in the way of building graphs in a certain way that each AS number represents a node, and the association, the BGP connection among these ASCNs represents an edge. Like in the corners, there's a full topology of the national-wide Brazilian IXPs. So here's the AS level graphs. We can see there's the connectivity between the AS numbers. And the red dots is represent you can see the representation of the IXPs. For example, in the corner you see it's São Paulo IXP. So about the analysis, first there was a classification, a manual classification about the IXPs profiling. So we defined the classification manually, entering like the web page of the profiler and getting data from the project itself. We classified all the members of the IXPs as internet providers, service providers, public organizations, and private organizations. This representation here is just to show you that DF is a small IXP, MG and RJ are medium-sized IXPs, and RS is a big IXP in Brazil. SP is São Paulo. We had issues in collecting the data in São Paulo. We saw that there were some inconsistencies in the data, and when we contacted the maintainers of the IXP, they confirmed that there was a problem to getting the data from this IXP, and the routing tables were being filtered. So we didn't consider neither this from São Paulo, neither one from Paraná in our data set. So some analysis of this data is that we saw that access providers dominate the connection in the IXPs. Mostly because they want to peer, they want to get to establish peering with everyone in the IXPs, and it's free. So in the capital, like in Brasilia, in the IXP of Brasilia, we see that things are a little bit different because there are a lot of governmental agencies that are peering among themselves. There's like a few, but some heavy content providers. We could check. There's some content providers that when we asked the maintainers of the IXPs, they answered that the few of content providers are responsible for a lot of traffic in the IXPs. There is a low presence of private companies. We don't know exactly the reason, but we think that's maybe because these IXPs are recent in Brazil, and they're trying to establish some business model to peer. So there's a lot of incentives to lead the predominance of open peering in the contractual definition of the association of the peers in the IXP. Most of them goes for open peering, but we are going to see that not all of them actually peer with each other. And there's a low presence of ASs in the multiple IXPs. Only big internet providers. So one analysis of peering density is like the amount of the actual peering, establish BGP connections in IXPs over the total amount of possible connections. We show that in Brazil you have a certain density of 44% in all IXPs. In comparison with European like IXPs, have 79, 95% in big IXPs. The peering metrics from a medium IXP and a big one here shows us we built it to visualize if we could get something interesting from them. We have here the classes of the peers defined that in the classification previously established, and the gray pixel shows that there is peering between the autonomous systems, and the white one's no peering. So we could visualize it, and the last row shows the total overall peering with the other class. Based on this matrix, we would like to quantify this peering analysis, and we went for the definition of a metric called peering affinity, defined in this paper. The definition of it is like to understand the affinity of peering between different types of autonomous systems, in the way that how we classify them. So 1, 2, 3, or 4 classes, and the other one. And so in this way you could measure how much each type of autonomous system is peering with the other class. Here's we built the national-wide peering affinity matrix, and we could see that the visualization corresponds with the data that we got, that usually big internet and transit providers peer among themselves. There's some peering here in like 3.2, 3.1 that some government agencies peer with transit providers, especially biased by this capital. Okay, one analysis about the vertices degree. We show that usually the vertex degree distribution, we have a certain degree of the graph of 5 to 10 degrees in most of the graphs, and in a big IXPs you have certain degree of 10. The depth of the announced AS paths, it's in the average of 5. We can see there in the curve of São Paulo, it's one of the way that we identified that São Paulo was filtering the routing tables, that it's the biggest IXP in Brazil, and we could find that the depth there goes in a strange behavior in comparison to all the other IXPs. And finally we could find that as well there's AS prepending. There's like a way of the autonomous systems try to avoid or making certain traffic engineering, adding the AS path multiple times in the announcement of the BGP routes. And we could find that this is common in Brazil as well, certainly like 50% in all AS autonomous systems announced routes with AS prepending. And the conclusion then, the main contributions of the work is that this is a new knowledge of interdomain connectivity in Brazil. All the data, all the algorithms, all the code in Python and Java, it's fully available on GitHub. You can use it. All the data set is also available. You can reproduce all the experiments here. We defined this new peering affinity metric between different classes or types of autonomous systems. This is a new public data set. The idea is to keep it updated with time. And as a future work, there's a PhD student fully dedicated to make more analysis on it in a temporal way, and get this data as a source of information and support it certain machine learning or data mining algorithms to extract more information of it. So thank you very much. Please, if you have any more questions or deep questions, contact the author, the main responsible one, but please feel free to ask me. If I am capable, I'm happy to answer. Thank you.